minus f del g upon del y, and in last from minus f common cut del f upon del z. Thus we get g del f upon del x, del f upon del y, del f upon del z minus f del g upon del x, del g upon del y, del g upon del z upon g square. Again we see that it is the grade f or a del f, and this is the definition of grade g or a del g. Thus we get g del f minus f del g, which is upon g square, which is our required result. That means left and right hand side. Now we see one example. If fxyz is equal to xy plus yz plus zx is a scalar valued function, then find grade f or a del f. The first of all, here fxyz is the given xy plus yz plus zx, and the definition of del, we know that del upon del x, comma, del upon del y, comma, del upon del z. Now we find grade f or a del f. We know the definition of del f or a grade f is equal to, we have to do the differentiation with respect to x, y and z of the given function respectively. Here we first differentiate the given function f with respect to I, comma, then we again differentiate the given function with respect to y, and then we again differentiate the given function f with respect to z. So here we get del upon del x, xy plus yz plus zx, comma, del upon del y, xy plus yz plus zx, comma, del upon del z, xy plus yz plus zx. We know that when we do the differentiation with respect to x, that time we consider y and z is a constant function. So here when we differentiate with respect to x to this function, that time we know that the differentiation of x equal to 1. So we get from this term only y. Here there are in this term there is a no x, so thus the differentiation of zy is equal to 0, and in third term the differentiation again x is equal to 1 into z, thus we get only z. The differentiation of this term with respect to x, we get y plus z. Again we differentiated del upon del y, that we differentiate this function f with respect to y, that time we consider x and z is a constant. So thus we know that the constant function, the differentiation of a constant function equal to 0. Thus, and the differentiation of y equal to 1. Thus we get from this term y is equal to 1 and x into y 1 is equal to x. Here is also the differentiation y into z, thus the differentiation y is equal to 1 and z is a constant, thus 1 into z is equal to z. Again there are no y, so that the z into x is the constant for y, and the differentiation of zx is equal to 0. Thus we get here x plus z. Now we do the differentiation with respect to z. That time we consider x and y is a constant. Thus the differentiation of x and y is equal to 0. Thus in the first term there is the no z, so the differentiation of x, y is equal to 0. In the second term the differentiation of z is equal to 1 and y into 1. So we get y, and in the last term the differentiation again zx, the z is equal to 1 into x is equal to x. Thus we get y plus z. Thus the given function fxy, the gradient of the given function, we get grade f del f is equal to y plus z, x plus z y plus z. So here we can see that the function xy plus yz plus zx have only one term. That means it is a scalar valued function. It's converted in a three component. There are not only one term. We write in a comma, in a vector notation. So del f is a vector function. So the gradient function is a function which convert the vector valued function into the gradient function. Now we see the another definition, divergence. The divergence, if the vector point function f x y z, f1, f2, f3 are the function of x, y, z. Also we use only three component x, y, z, and we can do all this process, gradient, divergent or curl, in a 2-dimension, 3-dimension or a n-dimension also. But we take the only in a 3-dimension way. The first, if we a vector point function f x y z, f1 x y z, f2 x y z, f3 x y z, and the first partial derivatives of f1, f2, f3 exist on an open set S, then the divergent at each point is defined by divergent f or a del dot f. Here dot is an important parts in a mathematics. The del dot f, that means is the dot production. Now the dot production is defined as del dot f, that means del by del x, comma del by del y, comma del upon del z, dot f1, comma f2, comma f3. We know that the dot product, when we do the dot product process, then we first multiply first component with in a second component, second part of the first component plus the second component of the first vector to the second component with the second vector, plus the third component with the first vector into the third component of the second vector, and we all do the addition. But here we apply the rules of the dot product, but here we have to do the first differentiation of the first component f1 plus the second differentiation with respect to y of the second component f2 plus the differentiation of the third component, that means f3 with respect to z. Thus we get del f1 upon del x plus del f3, del f2 upon del y plus del f3 upon del z. That means in the divergence we have to do the differentiation of the first component with respect to x, in the second component with respect to y, and third component with respect to z. Now we see the another definition called f. Curl f is also a vector process. The curl of a vector point function f x y z is equal to f1, f2 and f3 function, and is denoted by curl f or del cross f, and is defined as del cross f is equal to the determinant of I, j, k, del upon del x, del upon del y, del upon del z, and the function f1, the second function f2, and third function f3. That means the first component, second component, and third component. Thus we here see that the function, the curl function is of also apply on the vector notation, that means vector point function, and we get also the vector function. Here we can see the expansion of the determinant. We know that I keep in, if we take with I bar, that time we do the cross multiplication. First we do the second of column with respect and third column, and also in the cross multiplication like this way, del z upon del y to f2. So here we do the expansion of this determinant. So del f3 upon del y in this like f3 into fy minus we do in a cross section the differentiation of f2 upon del z. Now the we expand with respect to z, we get z. That time we use first and third column. So here again we do the cross multiplication, that means the differentiation. Here we do the differentiate f3 with respect to x, because here is a we do not use the in second column, we only use first and third column. So here del upon del x f3 minus we do in a cross section that we get the differentiation of f1 with respect to z. Now we do the last one with respect to k. That time we use only the column 1 and 2. Again we expand the cross section this way, del upon del x with f2. Thus we get the differentiation of f2 with respect to x. Now in the cross section in this way, thus we get the differentiation of f1 with respect to del y. This is the expansion of the determinant, and it is the definition of del cross f. So we have to remember del cross f is equal to I cap del f3 upon del y minus del f2 upon del z minus j cap del f3 upon del x minus del f1 upon del z plus k cap del f2 upon del x minus del f1 upon del y. Thus we see that the curl function is convert vector to vector. Thus the function is also vector point function and the curl function is also vector point function. Similarly, we see that in a definition, solenoidal function, the another definition is the definition a vector point function fxyz equal to fxyz, f2xyz, f3xyz is said to be solenoidal if divergent f or del dot f is equal to 0 at all point of the function. We know that divergent is a function where we use the vector point function and we convert it into the scalar function. The divergent function is nothing but if we enter the water or any fluid in any object, then it's come out from the another side. That time suppose we put the water in the any contain any box and it come out from the opposite side from the box. The water come out from the opposite side of the box is called the divergence. So here we write for such a vector if there is a no loss or no gain of a fluid, that means if the water enter in the box, the water enter the box in the same speed it come out from the another side of the box, then the divergence have a no loss or no gain. When we get divergent f is equal to 0. But if the speed is the greater than or less than, that time del dot f greater than 0 is called sources, and if divergent f is called less than 0, then is called sink. Thus divergence is the very important function in the physics and our real life. Second, irrotational field. The definition of irrotational field, a vector point function fxyz, f1xyz, f2xyz, f3xyz is said to be irrotational if curl f or del cross f is equal to 0 at all points of that function. Otherwise, it is said to be rotational. That means if any object in a river, if it's go ahead with rotated position, that time it has a curl, but it is not rotated and keep it is the position in only one position and not rotate, that time it's called of f is equal to 0. Now we see the example. If fxyz is equal to the vector function, we can see it is a vector function. Then find divergent f and curl f at the point 1, 0, 2. We cannot find the grade f of this function because we know that gradient is used for the scalar function, not vector function. And similarly, the divergent and curl f does not find the scalar, does not use for the scalar function. So here we cannot find the grade function, only we find the divergent f and curl f. First we find the divergent f. So here fxyz is equal to this one is function. Here we in our definition we called it f1, we called it f2 and we called it f3. Here the function is made by xyz component, xy function and xyz component. Now we first find divergent f. Thus we write the definition of divergent. Divergent f del dot f, del that means del by del x, del by del y and del upon del z, and the dot product with respect to our f. The f that means this one is f1, this one is f2, this one is f3. The dot product and the definition of divergent at this point, we have to differentiate this component, that means f1 with respect to x plus this component f2 with respect to y and this function f3 with respect to z, and we have to add all the different. Thus we get del by del x, x y square z plus del upon del y minus x cube y cube plus del upon del z x square y z cube. Again we know that the differentiation